All right, welcome everyone. Thank you for coming to the Muskegon Community College Lecture Series. It's great to have you here tonight and with our speaker, Ryan Wheeler. Ryan is a former graduate of, or is a graduate of Muskegon Community College, and so that's a special treat for us tonight to have that, especially during our 100th anniversary. It's 100 years of MCC, so we're celebrating all year long. The Muskegon Community College Lecture Series has been around for 25 years, and so about a quarter of that time we've been bringing lectures every semester to the general public and the students here. And the idea is to bring ideas that we might not get in the classroom. Even though we got great instructors here, there's also great people throughout the world in our region that can enlighten us in ways we didn't think or couldn't have here. And so we're looking forward to tonight's talk. The lecture series, this is the last one for this semester, but it continues on next semester. We have three talks scheduled right now. One is Pechakucha, which are 20 slides, 20 seconds. Sue here did one last night. Yeah, just for you, Connor. One of our maybe not best instructors right there. No, very good, very good. Anyways, 20 slides, 20 seconds per slide. Sue did a great one last year. We'll have 9 or 10 people presenting. That's on January 29th. And then on the 16th of March, we have a talk on climate change by a professor from Texas A&M University. And then we have a professor from U of M coming to speak on March 30th on AI, artificial intelligence. So we have a website. It's called just Muskegon Community College Lecture Series. That's all you really need to know. Google that, and our website will come right up. We have a page with all that on there. So a little bit about tonight's speaker. Ryan Wheeler is a senior fellow of advanced visualization and applied research technology at Collins Aerospace. He says that's an RTX business. RTX used to be called Raytheon and is a defense and aerospace company. They do things from airplanes to outer space to defense, all that type of thing. Ryan is an engineer and inventor working in advanced visual technologies. He invents apps that make it very easy to do very difficult things. Ryan's a gifted speaker and has spoken to business and professional groups as well as colleges and universities around the country, always sporting jeans and Jordans as he speaks. And there we go. And tonight, a very nice shirt to go with it. So please help me welcome Ryan Wheeler, his Jordans, and his talk, Make to Innovate, How Impactful Innovation Happens Through Modest Making.
Thank you, Dr. Weibel, for the invitation tonight. Thank you also to Amy Swope, who, when I said, how else can I give back to the university? She got that twinkle in her eye, and next thing I know, I'm talking to Dr. Weibel, so I very much appreciate that. Also need to say thanks to Iowa State. Iowa State University has a program called Make to Innovate, which is sponsored by Collins Aerospace, as well as Boeing. And that was the first place where this lecture was given a couple of years ago. And when this opportunity came up, I was like, well, it was well received then, so maybe it'll be well received now. Also, a thank you to, since this is going to be online, it sounds like I'll go ahead and say thanks to my mentees in the innovation space and early career mentees, because the stories that we're going to cover here are very much kept alive and kept fresh in my memory as I'm working with them. And thank you all for being here tonight. I was told that there's a lot of 100-year anniversary celebrations going on, so your presence here tonight means an awful lot to me. The intended audience for this, I added this slide at the last minute because I realized that not everybody in the room is going to be a technologist, and not everyone in the room is going to be working for a big company. And a lot of times, innovation, unfortunately, has the perception of being related to technology-oriented fields, and especially with large companies with big honking projects. But innovation, in my experience, is everywhere, all the time, every field that you can think of, because perfection is an illusion. And that's a really beautiful thing, because especially with like this age of AI that we're coming into right now, it means that no matter how good things get, there will always be opportunities to make things better. And that means that as long as you're somebody who's thinking about how to find those bigger, better ways, there's going to be a demand for you. And that's what this talk is about today. So I'm going to be talking about Collins Aerospace, and I'm going to be talking about RTX. And to give you an idea of who we are the biggest aerospace and defense company in the world. We're bigger than Boeing even. It's kind of crazy how large this company has become. It's comprised of 3 organizations that have more engineers, almost by a factor of 2, than Muskegon has human beings. I mean, that's massive. The part of the company that I work for, as you heard, is Collins Aerospace. We also have Pratt & Whitney, who do engines, and we have Raytheon, who does defense systems. Every second we have an aircraft takeoff that has our equipment on it, and we have a significant footprint. Really great company. Dr. Weibel gave a great introduction, Senior Fellow of Advanced Visualization. I'm based out of Cedar Rapids, Iowa, live slightly outside of that area. I work in applied research and technology within Collins Aerospace. I am president of the Augmented Reality for Enterprise Alliance, and I am home here. Like, this is amazing. This is like hallowed ground for me. I love Muskegon Community College. 2024 Distinguished Alumnus. A little bit about me. My family's up there in the upper left-hand corner. My wife Amy is also an engineer at Collins Aerospace. She designs and builds airplane cockpits in a lab environment so that we can make sure that all the equipment that we're going to be putting into that cockpit works well together. That's what she does. Our son Malcolm is a gearhead. That guy right there can take a Apache engine out and put a new one in 45 minutes. That would normally take a soldier about 4 hours to do. Our daughter is an applied, this is a mouthful, applied and computational mathematical sciences major at Michigan Technological University, and she wants to use that to make the world a better place, improve the oceans, improve the environment, put math to those good uses. Lower right-hand corner, I'm a cyclist, do about 3,000 miles a year. If you're on Strava for any reason, my handle is Wheels on White. I'm a writer, I'm a reader, I am a lifetime member of Girl Scouts. I'm a sneaker geek. I've got over 40 pairs of sneakers. The little picture you see right there, that's a Shepard Fairey piece that's in my living room. I'm a street art fan. And the group of people that you see there is my second family. I volunteer at a food pantry every Tuesday, and we see about 200 clients a week. I've been there for 10 years with them. I am a Jayhawk, I am a Husky, I'm a Cyclone, and I am a Hawkeye, but I am forever a Jayhawk. And you can see my employers there. My very first employer in the technology space was Muskegon Community College, and from there I went to Brunswick, Donnelly, Collins Aerospace. My passions at work, open innovation first and foremost. The cool people running around Collins Aerospace, seeing opportunities to make things better, and they're coming up with Excel-based applications of all things that are automated and saving people time, digitizing whiteboards, and just improving our processes. Those people are my heroes, and those are the people who I am a fellow to serve at Collins. advanced visualization, of course, all the headsets, virtual reality, mixed reality, augmented reality, smart glasses, and assisted reality, but also web applications, digital twins, and things like that. And I'm a geek about experience design. I see good design and bad design everywhere I go. I come kind of skipping out of an IKEA bathroom with this picture on my phone. And I'm geeking out about discoverability and signifiers and mapping and the use of colors and this eco-friendly flusher in the stall that I was just in. And I look at my daughter and she's doing this. And I quickly take that picture and then I show her the picture and I say, hey, Aliana, what were you thinking when I took that picture, when you were giving me that face? And she said, you're lucky I love you, Dad. So that's a little bit about me. Now, this is going to be a series of stories over the course of my career that show how almost all effective innovation that I've certainly had experiences with have started modestly, have started by getting your hands dirty, just trying things, kicking the tires on ideas, and the surprising ways and places that those things have come up in my career. So the first one, Make to Discover, this is from around the 2000, the year 2000 timeframe. I graduated from MCC in 1997, so this is about 3 years after I graduated from MCC. Up there at the top, I started at MCC as a lab tech, and that opportunity led to Brunswick, and I was at Brunswick for about 3 years before I said, hey, I might be able to be an engineer. I never thought that being an engineer was anything that would ever be in my future. But my time between here and Brunswick made me think that maybe that was a good idea. And while I was at Michigan Tech, I took this internship for all the wrong reasons, namely the money. Because they promised me that I was going to be, and a whole bunch of others, they promised us that we were going to be making 6 figures by the end of our internship. I'm like, that's good money. I like that idea. So I signed up for that job. And I had no intention of doing anything where I was going to be climbing telephone poles, but that was one of the things that we were going to be doing in that job. So wouldn't you know it, on the very first day of training, I'm coming down a telephone pole and I'm wearing a pair of these climber gaffs that have these sharp spikes on the inside of the legs. And I miss the pole and I drive one of those gaffs right into my right leg. And did me right, you know, because I was there for the wrong reasons. Intent matters. And it was when that employer, who's not going to be named anywhere in this entire talk, I do my best to forget their name, when that employer started sending me medical bills, and I was following up and saying, you can't be serious, this is a workplace injury, that's when I knew that this was not a good place to work. This is not an employer of integrity. And so I quit my job. And that was the only internship that I had had in the time that I was at Michigan Tech. And I was like, this is going to be really bad. I've got to find a job. I've got to find a job. And back in 2000, the internet wasn't what it is today, where you could go to LinkedIn and things like that. You had to sign up with something called Monster to be able to go. And some of you guys will remember Monster.com. Had to find a job. And I exhausted all my resources. Michigan Tech was really of no help. And I had one more card to play, and I came to MCC, and I walked into Bill Tokar's office, and I said, I need your help. And he said, come back tomorrow. And he had found somebody who had just lost an engineer at Donnelly Electronics, and they were looking for somebody to finish a test rig that looked a little bit like this, that you'll see on the next slide. Wanted me to go out there and interview for it. And so I interviewed, and little graphic up there above the Michigan Tech logo, the job was to program in Visual Basic. And I was an electrical engineer. That's what I was going to school for. I hated programming. I sucked at it. I was a hack when it came to programming. But that's what that job was. And I needed that job. And so when they asked me, do you know Visual Basic? I said, I do not, but I will do everything in my power to learn it. And sure enough, I came in and dedicated myself fully to that, picked up Visual Basic, and well, this was the test rig, or a likeness of the test rig. I don't have a picture of it, of course. And it tested 256 of these parts that are in these mirrors. And it had three outputs, a table output, a graphic output in Excel, and you could also export it in Excel. And then as people were using this, I was noticing that when they were looking at the data and then going to the rig, they were having a really hard time finding the parts that had failed or were kind of marginal. And if the person who had originally designed this, who had left the company, had designed it with rows and columns, those things would have been a lot easier to find. It would have been more natural. But because this kind of cool looking design was what they went with, this is what people were really struggling to find those parts with. And observing people engaging with the technology, I was like, there's got to be a better way. And so I created a digital likeness of that test rig so that whenever the test ran, what spit out was something like this. And just in a split second, all of you know where the problem parts are and the questionable parts are. Nobody needs to look at a graph. Nobody needs to click any exports to Excel or anything like that. And people really liked the interface. And that was the point where I was like, I kept finding myself in a state of flow. I didn't know what the term flow was, where you're losing track of time and you love what you're doing. But it was in this job that I realized that even though as a student I didn't like programming, I loved it when I was actually doing it for my job. So make to discover what this is really all about is if you're in an opportunity to like get a rotation program, or if you're an employer and you have the ability to give a rotation program, the beautiful thing about rotation programs is that they expose you to a bunch of different things, and you might come across something that you never would have guessed that you love, and it becomes your calling. You discover that it's the place that you really belong. And you know, huge props to MCC, because I wouldn't have found my calling if it were not for the help that Bill Tokars gave when I came back to the school 3 years after I graduated, saying I could use a hand, I need some help. So that's Make to Discover. Between 2000 and 2003, so this story is from around 2003, I graduated from Michigan Tech, and I hired into Rockwell Collins, which has since become Collins Aerospace. And our comms folks don't like me bringing up this, but it happens in all companies, no matter how great they are. And Rockwell Collins was and is a great company. The team that I joined, we were contractually delinquent. We were having a hard time getting our first units out the door for this particular radio, ground radio and a flight radio that goes into that really cool Swedish fighter jet, the Saab Gripen. And we had vice presidents and our morning stand-ups, and there was just a lot of stress. My parents are with us tonight. They were fielding calls from me, and I don't know what I've done. This is really, what am I doing here? And that was the hard part. The great part, though, was that this experience taught me what it's like to be on a really excellent team. This group behind me, they were another instance of a second family, really fantastic people and really grainy photography. It's amazing that digital photography survived when you look at that picture. So while we were trying to get back on schedule, I noticed that at the end of the month, our financial analyst, Julie, would disappear into her office for a couple of days, and she would come out looking absolutely drained. And I went to her after I noticed a couple of this happening a couple of times, and I said, hey, what is it that you do that's like so demoralizing or whatever? And she said, I have to use a whole bunch of these different systems in order to pull together our performance reports for leadership, for management. It just takes a lot of time to do that. And I said, you're doing it 2 days a month. I had just learned how to program in Visual Basic. That's a handy skill. And so I went to my boss and I said, hey, I think that I could automate that task for Julie. And my boss, this gentleman in the pink shirt here, J-Mac, wonderful, wonderful leader, one of my best leaders that I've ever had. He said, no. He said, we need you on the floor. And and I said, okay. And I reasoned to myself, you know what? I'm already working the maximum number of hours that the company will allow me to work. If I come in on nights and weekends, no harm, no foul. I'm just trying to help the company, right? And if they fire me, then this isn't a good place for me to work like the other place that I had left wasn't a good place for me to work. So this is a little bit of a test. And it was also something for me to do that was creative because, you know, we had 20,000 employees at that time. And there had to be 20 other Julies within the company, and that's like 2 years worth of people's time that would be returned to those people. Well, as soon as I started to create it, I had a better idea. And the better idea was that if I could automate this report for Julie on a monthly basis, why couldn't that report be automated on a daily basis? And if it was automated on a daily basis, rather than us finding out retroactively after the fact that our performance was bad, we'd be able to see that our performance was bad as we were going through the month, or where it was bad. That was the bigger thing. At the time, and so that idea is the concept of and-on. And-on is if you go into a factory and you see these lights, like you see up there on a machine, when an and-on light turns red in a manufacturing environment, everybody's supposed to drop what they're doing and supposed to go out there and help whatever it is that's causing that and-on light to be red. The problem was that our technicians and operators didn't like asking for help because they're human beings. Human beings don't like asking for help for whatever reason. We have pride. That's probably what it is. And every 3 days, we were supposed to output something. So I created this where if 3 days passed and nothing happened, it lit up a cell for me. And it let me know that there was somebody out there who needed help who wasn't coming forward and asking for help. Well, up to that point, we had only been in the mid-40s for productivity. Everybody considered it to be our most difficult metric. And really the attitude was, we need to improve our performance, but nobody's really seen this move much beyond 45% for the last 2 years. So it's just what it is. As soon as we started to use it, we saw a 15-point increase from what we had seen the entire previous year because we knew that there was a problem that needed to be fixed. And then the technicians got smart and they started saying, how is it that you know that there's a problem and you're showing up and asking us about these things before we ask you? And we were like, well, we kind of know because we're using this tool now. And you can see the other step increase up above 90% for a month, or actually kind of 2, because the technicians and the operators at that point were like, well, if they're going to come out, I might as well beat them to the punch and tell them that I've got a problem as soon as I have a problem. And then the JMAC, the leader who was like, you can't do this, he said, this is fantastic. And not only that, he said, the 70% goal that we've got, I'm going to give you a stretch goal of 85%. And within 3 months, we were above that 85% stretch goal because we started building it into our morning stand-ups. And happy to say, not only did I not get fired for breaking the rules, they also nominated me for Engineer of the Year. There were like 6,000 engineers in Rockwell Collins at the time. And kind of a pro tip, I had no expectation that I was going to win this. I was 2 years out of college, not going to happen. So I didn't prepare an acceptance speech. And then I got up in front of our executives and I made an absolute fool of myself because I didn't have an acceptance speech prepared. So tip for you all, no matter how improbable you think it is, always have something prepared. the point with Make to Evolve is that the first idea, and you read this in innovation literature all the time, the first idea that you have is always the worst idea. And that's the reason it's so important to start exercising those ideas, to get your hands dirty. Because in enterprise, a lot of times we like to spot a need, create requirements, put those requirements out, and see what happens. The problem with that is that those requirements are a reflection of that first and worst idea. And so that's the reason it's so important to get your hands dirty. And you know, luckily I found out that I was working for a really fantastic company. So Make to Fail, one of my fellows likes to say it's not failure, it's learning. And so in Ron Knight's, in honor of Ron Knight, I added the learn because I really like that perspective. And this was in 2010, and what happened between 2003 and 2010 was that I got recruited into our research and development organization because I kept having ideas for things like that thing that I just went through. And I was going off and doing them as a side gig, and my vice president kept calling me into his office and saying, "Great job," and then he'd say, "Great job," and then he'd say, "Great job," and on that third one, he handed me a thank you letter, a formal thank you letter, and said, "Have you ever thought," he said, "I don't want to lose you, but have you ever thought about starting your own company?" And I'm an entrepreneur. I like to innovate on somebody else's dime because I don't have the stomach for the risk that it takes to be an entrepreneur. It's just not in me. So by 2010, I had joined our advanced manufacturing team, and the thing that we were working on was a vision from Herm Renniga that I'll get to in just a second. If you think about the products that we make, at least, they're called mechatronics. They're partially electrical, they're partially mechanical. And from a producibility perspective, you can consider that on a 2x2 axis, where the vertical axis is assemblies on the top and parts on the bottom, and the horizontal axis is electrical on the left, mechanical on the right. And these three quadrants that don't have the red box around it, we were really good at those three quadrants. In fact, I'd say that we were industry leading and still are industry leading in those three quadrants. But this last one over here, the mechanical assembly quadrant, we didn't have effective ways to do that. We didn't have good tools. We had tried several tools. We had a producibility checklist. We were doing cross-sectioning. That wasn't working. There's CAD checking applications built into CAD software. Those weren't doing the trick. They were wrong as often as, actually more often than they were right. And 3D printing in 2010 was beginning to be something that we were seeing in enterprise. So we were starting to use 3D printing to prove out producibility. None of these things were working. So Herm, our senior vice president of operations, he was a technologist and he was a visionary. And he rightly saw that by the time we see these things in manufacturing, that mold has been cast. That design is not changing unless it has to change. We're not going to change it just to make it a little bit better, because it costs a lot of money to do that. So by prototyping, Herm said it's too late. We need a way to experience these designs in a manufacturing context before we start to cut metal, before we start to order parts. And Herm, being that technologist and visionary and connected to industry the way that he was aware of the fact that there were a handful of companies that were doing this already using virtual reality technology. So that I got brought into the team not knowing anything about virtual reality other than the fact that I had a Nintendo Virtual Boy back in the early mid-1990s. I forget when the Virtual Boy was out, but I had one of them. That's all I knew about virtual reality. They brought me onto the team to try to figure this out. So, did I skip something? Yep, I skipped something. All these companies that were using this technology, these are some of those pioneers, and some of them were, and still are, great assets for industry. Ford, Boeing, and John Deere in particular were mentors to us. John Deere chief among those three because they're a fellow Iowa company right down the road and we're not competitors with each other, and they were just fantastic to work with. But the thing about everyone in this list is that the stuff that they make is big. And because it's big, it means it's got big price tags. And big price tags means that if there's a design flaw, catching that design flaw and keeping it from coming into manufacturing saves a lot of money, like millions of dollars in some cases. For us, we're making small things. You'll see one of our products in just a little bit, but like radios, something about the size of a loaf of bread or two. And our cost avoidances from something like that are significantly lower. So these XR technologies, XR being an umbrella term for virtual reality, augmented reality, mixed reality, all of that, they worked well for them, but we were trying to use the same things that they were using, and it just wasn't working for us. We could not get it to work. It was too expensive, a whole variety of problems, just not effective. And it was around that time that Brittany Oswald stayed late after a virtual reality demo in what has been one of the most serendipitous moments of my career. And she said, "I want to work for you." And I said, "Do you know anything about virtual reality?" And she said, "Not at all." She said, "But I will do everything in my power to figure it out." And I went from that meeting into my boss's office, and I said, "We're hiring her." And he said, "What's she going to do?" I said, "I don't know." But that fire in the belly, she's got the job, as far as I'm concerned. And he went ahead and gave the go-ahead. She was going to be with us for 9 months. And during the gap between when that happened and when she actually joined us, we almost pulled the plug on this initiative because everything that we had been trying, commercial off the shelf, was not working for us. What else are we going to do? Well, just then, I saw a way that we might be able to pull this off if we made it ourselves. And Brittany was an undergrad in computer science at Iowa State University. And I went to my boss and said, "I think that this is the thing that I want to try to do with Brittany over the next 9 months. And I think I can chunk out the project into interrelated pieces so that it will feel like a big class project. And at the end, if we're lucky, we'll have a really cool virtual reality system that will allow us to do all the things that at this point, because we've been failing so much, we knew what we needed to do. All those failures were educating us as to what needed to be done. So at the end of Brittany's internship, this is what we had. We had a virtual prototyping solution that had three what's called modalities, three ways of experiencing those things. Powerwall virtual reality, we would fill a room. We've got a simulation lab, not this big of course, but a simulation lab, hold a bunch of people, put on 3D glasses, everybody can see in stereoscopic 3D and they're immersed in the design. Viper is the head mount display, and that's the one that everybody thinks of when they're thinking about virtual reality. You see Gavin there using with his virtual hand. You can't really see it because of the contrast in the projector, but there's actually a switch that's blocking access to a Phillips head screw that if that screw head got stripped out, we would have to get in there with a Dremel and cut that switch out, which is just awful. That's like the last thing that you want to do. So we identified that that screw needed to be moved out to a more accessible location. And the unsung hero, because everybody loves the virtual reality technology, the unsung hero is the interactive desktop application. Because everybody's got a computer, so everybody can use it. You don't have to have the special hardware at all to be able to use the interactive desktop. What we were hoping to use this for was to be able to find obvious and nuanced things. The obvious one up there, you see that little pink, now here's a place where I'd actually use the pointer. I'm not a laser pointer person. But that little pink triangle right there is the bottom of the screw hole. I think everybody in here sees that there's a problem with that. That screw's overshooting the bottom of that screw hole by about 1/4 inch. But there's actually another thing that can be done to improve this. That green sleeve right there is called a helicoil, and that's doing all the anchoring of that screw. So we can shorten that screw all the way back to that helicoil. There's like 6 or 8 of these screws, and they're chunky screws. If we shorten that screw by half the size, then we take a significant, not insignificant amount of weight out of that product. Less weight in the product means less fuel that's burned. Less fuel that's burned means better ecological outcomes. It also means lower ticket prices, because fuel burn is one of the things that drives our ticket prices. So two ways that that design could be helped. More nuanced, you've got this D-sub connector that's connected to this board through, they didn't model all of the individual wires in between, but there's like 30 wires there, each one about 1/4 of an inch, that would need to be manually soldered in. And we came back to them and said, hey, if you make that a flex cable instead, it will be higher quality, lower labor, and lots of other benefits. Well, the electrical engineer said that's going to add to my product cost, and the quality and design to cost person said, but it will save us 300% of that cost in every single unit that we manufacture, along with having a higher quality product. And for us, safety and quality is everything, everything. So that's a very difficult thing to see, to catch. The obvious thing, we're coming into the age of AI, right? The obvious one, an AI might be able to find that if it was trained to look for those types of things. These more nuanced things, you need a human being who has experience and can kind of perceive what that experience is going to be of that design to be able to catch that. So the first time that we used this was on the ARC-210 Gen 5, and this radio is it's the communications device for practically every NATO vehicle in the entire world. It's one of our most important products, and we're now, I think, on the Gen 6 of this. But at that time, this was starting to transition into production, and every time we built something, every time we put something together, it wouldn't fit. You put this in and it didn't fit, you put that in, it crushed the cable, whatever. And it had been stuck in new product introduction for about 3 months. And its program manager came to our boss. They happened to be married. It was very lucky. So that program manager came to our boss and said, hey, if you think this would have caught all those problems, I'll give you the model and let's see if you can find it and find those problems. You just can't have any knowledge that they existed. We're going to run this like an experiment. And sure enough, we found 100% of the design flaws that they had already encountered. 100% of the design flaws. We even found a handful that they hadn't gotten to yet because they hadn't built that part of the product. So they had that forewarning that that was there. That was at the end of 2010. And our boss came to us and said, I want you to use this on 20 new designs. And I said, we've been trying to make this work for like 3 or 4 years now. And we've not supported more than 3 designs in an entire year. And he said he wanted us to use it on 20. I said, you're signing us up for failure. And then the first quarter happened. And when the first quarter happened, we supported 3 new designs. And I felt like celebrating because we had just equaled our entire best year in all the years before. The thing that we didn't know in that first quarter, those 3 designs that we supported, those 3 designs were supported by what's called early adopters. And an early adopter is not the first person to use something. An early adopter is an influencer within that social system who is also the first person to use something. Because if somebody uses something within a social system and nobody respects their opinion, you're no better off. We got really lucky and had early adopters influencing early adopters as those first 3 people. And those 3 people started going out and telling all of their friends who are also high-performing people, because people of influence tend to roll with people of influence. So they were out there telling people, and the second quarter, we were right at our year's goal. It was all I could do to keep up with the demand. And at about that time, we brought in 2 other engineers from our team because the demand kept coming through. Third quarter, we were around 30. By the end of the fourth quarter, we had more than doubled the goal that our boss had set for us. And it has it had gone organically, it had gone across the entire company in the span of 1 year without it being a mandate. To date, this is the distribution of our return on investments, the benefits that programs get. And you can see that the average is in the range of 1,600 to 2,400%. Every single time we use this technology, the program that gives us money to use it, they get $20 back for every dollar that they give us to use this technology on their designs. So, and it's been used on over 500 designs. We never would have figured this out had we just written requirements and purchased some software. Because we tried all the software, and the software wasn't doing the things that we needed it to do for us. It was only through getting our hands dirty, trying things, failing, learning, that we were able to figure out what it was that was going to make it work. Whoever tries the most stuff and screws the most stuff up the fastest, that person wins. Tom Peters. So that's make to fail. Now, make to know. This is my last big story in this, and we'll have just one last thing before we open it up for Q&A. Make to know. So 2016. What happened between 2010 and 2016 was that I went back to college, and I never thought that I would be an engineer. I never thought I would have an advanced degree. And I went back to college to get my MBA and my Master's of Systems Engineering from Iowa and Iowa State, respectively. And in the course of that coursework, one of the texts it came up in both of those two curriculums, the MBA and the Masters of Systems Engineering curriculums, was The Diffusion of Innovations by Everett Rogers. And this had a framework, a list, checklist, whatever you want to call this, that resonated so true with me, and that's probably the reason that it kept coming up in our courses. And it said that the thing that determines, there's really 5 attributes. This has been proven thousands of times, by the way. There's really 5 attributes that determine whether or not something is going to be adopted by people in the world. First attribute is its relative advantage. How well, and this is the most important one, how well it compares to the other things that people could be doing. And one of the things that other people can be doing is nothing at all. They don't have to use a technology. They can do nothing at all. So user perceived relative advantage, what the user sees as how well this fares to other things that they could be doing. Compatibility with the norms and their past experiences. That's a big one, and that's one of the reasons why virtual reality and augmented reality and mixed reality technology is so slow to be adopted, because it's a completely different modality. Our phones, if I can do this without pulling my notebook out too, our phones were basically a smaller version of the laptops that we were already using. And that's the reason that this technology adopted like lightning speed. But virtual reality and augmented reality technology is probably going to be closer to a telephone or a television's rate of adoption. It took 10, 20 years for those technologies to become prevalent in people's homes, and it's probably going to be the same way with XR. Complexity, how easy it is to use, trialability. Can I go to a website to use something, or do I have to have special hardware to use something? Do I have to sell a kidney to be able to connect this device to our company's network? That's trialability. And observability is the ability for a person to kind of be walking through a space, see somebody using something, and then go, what is that, and how can I use it? Because I can see that it's significantly better than the other ways that I do things. And all of this is great, but the problem with it is that it's after the fact. To quote my cousin Lori, you've already burned the wheelbarrow full of cash at the point that most of us know whether or not these 5 things are there. So the question is, how can you know before you burn that wheelbarrow of cash? You do it by getting your hands dirty. I was in the process of taking our organizational behavior course in the MBA program when I read a single paragraph that was like a lightning or a thunderclap. I guess you don't have lightning claps, a thunderclap. And I was like, I had this just great idea. And it was a novel way to experience, to work with electrical designs, something that hadn't changed substantially since my days as a test technician here in MCC. We were doing things pretty much the same way that I was when I was a test technician in MCC. So I had this idea for this novel way to do this, but the problem was that we still didn't have any software engineers on our team. Even though virtual prototype modeling had done all the great things that it had done, we still didn't have any software engineers on our team. So what do you do when you don't have any money and you don't have any real schedule to do something with? I spent a weekend in front of the TV with football on the TV and making an interactive mock-up in PowerPoint. Today that would be done in something like Figma. And the intent of it was to give people a sense of what this alternative reality was. The intent of it was to make hope real. And I brought this into the company and I started setting up meetings with people just to kind of gauge whether or not this was something that they would like to have, thinking it would be a couple of years before I would get a chance to work on this, assuming that all of this went well. This is some of the actual feedback that came out of those sessions. People who were mad at me because they typed the URL into their web browser and nothing happened because it was a fake URL. It didn't exist at all. Or coming up and basically being threatened by an engineering leader that his site needs to be the first site to pilot this. Or a vice president general manager who was practically volunteering to throw engineers at me to accelerate the development of this. And another thing that we learned in the course of both of the systems engineering and MBA courses was this concept of the Gartner hype cycle. And I realized that we were seeing it happen in real life. People were throwing their wildest expectations on this thing. And that means that peak of inflated expectations was just going astronomically high. The higher that went, we reasoned, the deeper the trough of disillusionment was going to be. In other words, people were going to be disappointed that it didn't do all the things that we never promised that it was going to do. Virtual reality and augmented reality and mixed reality suffer from this tremendously. So in order to try to manage the hype, we reached out to those 80 or so people who had seen this interactive mock-up, and we said, shh, don't tell anybody that we're doing this. And they were like, but I just told my boss, and my boss wants to see it now. And we were like, too bad, we're not going. We want to harness that enthusiasm. We want to harness that energy so that when if we're able to actually create this, that will fuel its viral deployment. You know, that would be great if we had a viral deployment. So we were able to create it. And as soon as we started using it, as soon as we put it out there in beta form, we built analytics into it so that we could see what people were doing with it. And by building those analytics in, we were able to know, the previous slide was all about knowing that it was going to scratch people's itch. This slide is about knowing that how it was making a difference in people's lives, because those analytics allowed us to see how it was helping. And those analytics allowed us to put value to the different ways that it was being used. And once we had that value, we started to broadcast those numbers. And there were naysayers in the audience that we were broadcasting those numbers to, and they said, there is no way that this is doing the good for people that you're saying that it's doing. Well, then we were able to come in with user stories, which we had kept harvesting, because there's a saying in industry, you'll hear it a lot of times from leadership, figures lie, liars figure. And it's their way of saying you can fudge the numbers. And they're not wrong, it's possible to fudge the numbers. But when you have customer stories like Occam's makes it feel like I'm cheating, Or if Occam's vanished, engineering would riot. Or the person who fell in behind my wife and I when we were leaving work one day, and he said, Occam's guy, I like you. Or, the technician I passed in the hallway a couple of months ago. It was 6:30 in the morning. Nobody else was in the office. I'm guessing that this guy was a third shift technician. Never seen this guy in my life. I'm carrying my lunchbox. We pass each other in the hall. We make eye contact. I nod at him, and he goes, Occam's forever. Who says that about software? So it's those stories that give context to the numbers. And if somebody's going to call BS on the numbers, then they're calling BS on the people who are behind the numbers too. And there's thousands of employees who this application has become a daily centerpiece of the way that they do their work. I could tell you stories. So yeah, this is the world's fastest, easiest visualizer for electrical designs. It's used on over 10,000 designs. It's used by thousands of our employees, and it saved hundreds of thousands of labor hours. Everybody loves it. I've had electrical engineers leave the company and say, I'm going to work for such and so. I just wanted to reach out and tell you that the thing that I'm going to miss the most about working here is being able to use this application. So really, really great story. But the only way that we would have, there's just no way. There's no way that we could have known that it was going to be such an impact for people without getting our hands dirty and starting small and just trying to paint what that future could be, getting it in front of people and then deploying it in a modest way and seeing what happens, standing back and seeing what happens. It was only through that modest making that we were able to discover that there's no role in the company that people don't have some access to this or love and appreciation of this. So last slide, the neat thing about putting this talk together for Iowa State back in the day was that as I was going through all these stories, like I said, these are stories that they just come up over and over again with my mentees in innovation and early career mentees. As I was putting this together, I was thinking about, wow, is there a case where there isn't some major innovation that didn't start in a very modest way and then become something good? And I started seeing a couple of other things that were really interesting. I came into this hallowed ground, this fantastic institution of Muskegon Community College, as a near high school dropout. This is my actual high school transcript. 2.0094 GPA, 107th out of a class of 127 in Whitehall High School. I came so close to, I think my parents would probably tell you there were times that they thought that I wouldn't make it out of high school. But this place helped me learn to love. It gave me my first job in technology. Technician became engineer, became technical fellow, and at this point, I've been able to, through fantastic teammates, I have to say, I've been able to bring about a 300 million, actually, if we knew what the real number was, this is a very conservative number, it's probably over $500 million at this point, worth of benefit to the company. And it all started from the modest beginnings of remedial English classes, remedial math classes here at MCC. And even within our own company, we've got a similar story but different too, because Arthur Collins was like a genius. He's the namesake of our company. 15-year-old with quality as his focus and advanced technology as his focus, ham radio enthusiast, building a ham radio in his parents' attic in Cedar Rapids, Iowa. And he's able to keep contact with the Macmillan Arctic expedition long after even the United States Navy had lost contact with them. The story is, I don't know the truth of it, but the story is that his parents heard a knock at the door, they opened the door, and there were Navy officers wanting to speak to their 15-year-old son to use his radio to keep contact with this expedition. 1933, Arthur Collins incorporated Collins Radio. We became Rockwell Collins, part of Rockwell International in 1973, and in 2018 we became Collins Aerospace, now a part of the great company that is RTX. All from a project in a person's attic, $28 billion a year company. And so, you know, if you take away anything from this talk, the thing that I want you to think about is that whether it's Amazon or Airbnb or the modest bicycle or space missions. We had the communications technology on the moon mission. That was us. We made that happen. There's a really cool story behind that. They didn't expect that video was going to be a part of that, but our engineers figured out a way to package video within the signal, the bandwidth that we were given. And here's another really fun thing to think about. The Wright brothers were bicycle enthusiasts, and they're the people who created manned flight. And manned flight is what the space system, the space program came from. So in a very real way, the space program came from the humble beginnings of the bicycle. That's a really cool thing. Innovation is everywhere. It's in every competitive advantage. It's in your careers. It's in every company. And all of this almost always grows from the very modest, humble beginnings of just trying, just getting your hands dirty, no matter what it takes. And open it up to questions, but I wanted to add this. This picture came in last night from my family in Animos. My wife stepped outside and took this picture. It was cloudy here. It'll be interesting to see if we see anything like this tonight. But that was a state-of-the-art digital photograph in 2003. And this was an iPhone 16 that my wife was standing in the backyard with her arms at her side, no tripod or anything, and took this tremendously crisp picture. You can see the individual branches on the tree behind the house. The progression of those things and the modest beginnings of this. And one other thing to just kind of appreciate with this, back in 2003, I said, look at the crap quality of that technology. That's never going to replace film-based technology. I don't want a digital camera. I'm going to use my film-based camera and, you know, spend $15 to get 30 pictures developed. The reason that digital photography took off was because it's not just the quality of the photographs that's important. It's the short attention spans, the instant gratification, the instant awareness of whether or not you captured the thing that you intended to capture in that picture. And that's something that when we're talking about innovation in a lot of enterprises, we tend to latch on to a certain set of criteria, completely overlooking things like the ease of use, the instant gratification. Those are things that are as important, if not more important, than the quality for most users of this technology. And that's the reason why that technology ended up sticking around and has become the fantastic technology that's in all of our phones today. So thank you all. Open up to questions. I will say I am profoundly hard of hearing. You might have noticed that I have hearing aids. We've got a mic. I might need to ask you to repeat yourself. And if I do, that's on me. It's not on you. So.
Just raise your hand and I'll bring you the mic. So thank you, Ryan. So questions?
Who wants to break the ice?
Hi. How much of a role did probability and statistics play into innovation and everything that you guys do every day?
How much the bonuses?
Probability and statistics, like how much, like statistics do you have to put into your work?
As a company, we do a lot with probability and statistics. Me personally, not a whole lot. If I'm being completely honest, whenever I'm working with these technologies, the thing that I'm more, this is probably going to make you cringe a little bit, I'm very intuition driven. So whenever I'm using a technology, Temple Grandin is this fantastic scientist who does work with agriculture, livestock in particular. And she's a visual thinker. She has the ability to see in her mind the way that the future is going to play out, the experiences are going to play out for livestock as they're going through the things that they go through. I'm a visual thinker for digital solutions. So whenever I'm using these things, I'm paying attention to just kind of what my gut tells me, because I'm almost always right when it comes to, is this going to work for people or not? Once we start getting into the analytics side of things, statistics starts to play a little bit more of a role, because we want to know, like, what's the distribution of this thing? Whenever we see these benefits, whenever we're working with the almost 7,000% return on investment that you are seeing on the Occam's project, whenever we are surveying our employees about how much benefit is this particular aspect of it bringing you in your job, we want to have an idea of how tight is that distribution. Do we have extreme outliers? If we have extreme outliers, then why are those outliers? On the other side of that curve, if we have somebody who says it saves me very little time, and then there's somebody who says it saves them a tremendous amount of time, those outliers are very often things that are, we want to track them down and find out what it is that made them answer the way that they did, because the outliers a lot of times give you further insights. So I don't have a strong math background. I took all the calculus, all the differential equations, and all the linear algebra courses that we take. I got A's in most of those classes. My parents will tell you I had to retake several of the calculus classes to get the A's in our calculus courses. But yeah, I hope that helps.
Other questions? Jesse.
In XR environments, are you leaning more toward cloud-based computing or hardware-based? And what's the healthy balance there for you in your work?
We're actually making a little bit of a transition right now. Everything that we did started out in 2010. There was really no such thing as the cloud in 2010. So in 2010, this was all running on device, locally. Occam's is more of I think you can probably call it cloud, but it's internally driven, and we're seeing tremendous performance from that technology on Occam's. Next generation of virtual prototype modeling, it's probably going to be cloud-based, and the thing that's interesting is how many of the new technologies that are commercial off the shelf. I mean, virtual prototype modeling is still in-house, and there's an increasing number of technologies that are competitive with it. There's things that are coming out that it's like we're looking at and we're saying, it's not quite where we think it needs to be for us to make the switch, but things are getting really close. And almost all of that stuff is cloud-based. Technologies are improving all the time. And AI is a big part of that too, with the data centers and the speed and performance of those computing resources.
I got a question. Very good talk. Thank you. When you talk about getting your fingers dirty and getting in there to look at things, I just wondered from since you're a manufacturing company, you got like designers, you got engineers, you got customers, and when do they get involved? I mean, I know there are different parts of that, and the work that you've done, is it mainly for the engineers, but is also for would the customers get involved in focus groups and whatnot?
That's a really good question, and it's interesting because when I went to get my engineering degree, my motivation for getting my engineering degree was being a technician in Brunswick and seeing some of the designs come through that I was like, I would have made this more manufacturable. And because I've got that background in manufacturing, I'm in a position where I can do that. So if I become a design engineer, then I can make these tremendously manufacturable designs. And I came into Rockwell Collins with that being my intention. And one thing led to another, and I ended up in advanced manufacturing. And lo and behold, the first thing that I was working on was a virtual reality solution that was focused on not just making one design more producible, making all of our designs more producible. So for us, producibility starts at the earliest stage of the design. Virtual prototype modeling in particular, because it is virtual reality technology, it allows us to be able to experience our designs at an earlier state than we would ever be able to before. As soon as we have a CAD model, we can bring it into our virtual prototype modeling environment and we can experience it in a virtual way, in context, doing the things that we would do with it in manufacturing. And that allows us from as early as conceptual design to say, okay, we've got, and this is an actual example, we've got 6 concepts of this design that we're considering to bring into our next stage of design and development. And we're going to put all 6 through virtual prototype modeling. And we tell them the good things and the bad things about each one of them, bring everybody together in our lab, eliminate 3, take those 3 that are remaining. We take the best ideas from all the discussions, build them into those 3, but they're still different in some way, do the whole exercise again, and narrow it down to 1. And then when we come to what's called preliminary design review for us, we have a very well thought out design where manufacturing has had a say, mechanical engineering has had a say, thermal designers have had a say, electrical engineers have had a say, reliability engineering has had a say. Like all the stakeholders have been able to come in and have a say on the way that this design is going to be before we get to preliminary design review. To my knowledge, that is a capability that we have that I'm not aware of any of our competitors having that level of ability. So the earlier you can bring in stakeholders, the better the outcomes are going to be for everybody involved. And this technology, both of those technologies, allow us to engage people earlier in the design and development process for everybody's benefit. Our customers, our employees, our shareholders, everybody.
Thanks. Other questions? Well, I got one other thing. Just wondered, maybe some people are thinking this too. Can you tell us what you're working on now? That I know maybe there's some things you can't say, but what can you say, and what are you working on now that you're excited about?
I'd say that the big thing that we're doing some next generation things with Occam's that I can't get into detail with. You'll notice that I was very scant on the details on what exactly it is that Occam's does. That's because I'm not allowed to get into the details on what exactly it is that Occam's does, but some very, very next generation things there. And then the other big project that I was working on this year is factory digital twins. You know, factories are very dynamic environments, and everybody has a need for, if you don't, digital twin technology is basically having a digital likeness of a physical asset that can be used as a visualization and control front end. That's the ideal state, and even predictions. Being able to use that thing to predict the future. That's one of the ideal states for digital twins. We have an entire, and everybody does, everybody has a deep need for factory digital twins. And we have model-based manufacturing type activities that are very mature within our company, but digital twins in particular are very difficult to do because manufacturing environments are organic environments. So if this machine over here gets moved a couple feet or gets moved entirely, and nobody updates the map that was representing where that machine was at, well, now I've got something that says that there's a problem with that machine and it's drawing it at this spot on the map, but that machine was moved over there last night. And now I've got a disconnect between what the model says and what the physical environment says, and the physical environment is changing all the time. So how do you have a digital model that is intelligent and interactive, that is also able to adapt to the organic realities that we see on our manufacturing floors? And that was one of the big things that I was working on this year. Great team also.
Other questions?
Any other questions?
All right. Well, thank you very much.
Thank you all for being here.
Great. Good night.